All right, hello everyone, and welcome back to our web dev intern training. This week, we're going to talk a little bit more on how we can do some extra concepts in React, as well as how we can make different web apps using TypeScript and what exactly makes TypeScript different than JavaScript, which we used in the past. So first, let's go a little bit and see what exactly is JavaScript versus TypeScript, and why, as a dev team, are we trying to switch to some projects to using TypeScript in the future? Well, first, let's see what exactly makes people like TypeScript. And if you look here at the 2020 Stack Overflow Developer Survey, you can see here that these are some of the most loved languages in the world. And you can see something quite interesting. It looks like, according to the survey in 2020, TypeScript was the #2 most loved language in the world, while JavaScript, on the other hand, was only ranked number 10. And to highlight why this could be the case, let's go ahead and write some code in JavaScript and see how TypeScript can help solve these issues. So let's go into our Tips.js folder. And is this big enough? I'm going to make this a little bit bigger. There we go. Oh, this is the wrong one. Interesting. Okay, let me go to the right folder. Where is TypeScript? There it is. And let's make a scripts.js file. And within here, let's say that we want to make a function that divides two numbers. And we know how to do that. We do function divide two nums, a, b. We want to return a divided by b. And this does as we expect. Let's say if we console.log divide two nums of, let's say 6 and 3, we're going to get, as we expect, let's see the TypeScript. What happens is that if we run scripts.js, it tells us 2. And the reason for this is because divide two nums takes in two numbers, 6 and 3, and divides them. What if, for instance, we did something else? What if instead of dividing 6 divided by 3, we divided, let's say, ACM and IEEE, 2 clubs on campus? If we try running this, what do you guys think will happen? Will it give us the intended result? And let's see what happens if we do actually run this. If we run node scripts.js, it tells us that what it prints out is not a number. And that's because divide two nums is supposed to take in two numbers, but it didn't really tell us anything saying like, oh, it still works, despite the fact that divide two nums should only take in two numbers. And the reason for this is because JavaScript is dynamically typed. What this means is that JavaScript does not know the types of variables or the return values of functions until runtime, and it doesn't do any static checks on whether or not the types of something are. And to iterate, as you remember, the really common types within JavaScript and TypeScript that we covered last week are numbers, strings, undefined, big int, null, and a couple more here. They're like symbols, whatever. And these are all just different primitive types within JavaScript. So now that we've seen a common possible issue of JavaScript where we try calling a function on two things that don't necessarily work, let's see how we can use TypeScript to fix that up. And first, let's see how can we write things in TypeScript. Well, what we can see is that what TypeScript is that it is in fact a superset of JavaScript. What this means is that everything that is valid JavaScript is valid TypeScript, but not everything that's valid TypeScript is JavaScript. And this is because what TypeScript allows us to do is that it allows us to write code that at runtime gets compiled into JavaScript. And for an example of seeing how exactly this works, let's try and initializing TypeScript within our project right now. And real quick, if you guys want to use TypeScript on your own projects at home as well, you're going to need to use NVM, or you have to use Node in order to run it. And if you need, we have it inside of our third session, how exactly we can install Node and Yarn on our machines, which we'll be using for today, like so. So to add TypeScript to our application, what we're going to have to do is that we have to yarn add TypeScript, which is because it is a node dependency. And once we have added TypeScript to our application, something that we're going to want to do is that we're going to say yarn tsc -- init. And what yarn tsc -- init does is that it creates a giant like JSON file for us. And we'd be like, what is this giant JSON file? Well, this is basically our TypeScript configuration. And as you can see here, there's a load of different things we can change. But for now, we're not going to change anything. So now let's make our first TypeScript file. Let's try making something called TypeScript .ts for TypeScript file. And let's do the exact same thing we just ran, making the function divide two nums above. Right away, we can see that TypeScript is yelling at us. It's saying parameter A implicitly has an any type. So like what we said before, JavaScript, everything that's valid JavaScript is valid TypeScript, but something is that by default, TypeScript has it so that you cannot have the type of anything be like any. And any type means that it can be dynamically checked and be any type at all. By default, what TypeScript wants us to do is assign types to different parameters. Like for this case, A, what do you think our divide two numbers function should take in as their parameters? Strings, numbers, you guys can just type it to the chat if you want. Number, yeah, exactly. So the way that we can denote to TypeScript that we want A and B to be a number is by putting a colon and the type of our parameter, like so, lowercase number. And what we can see is that now it says that we have our function divide two nums, which takes in a number A and a number B. If we had a slightly less contrived function that you don't really know like what the return type is, we can also assign the return type of a function by putting a colon after the parameter list and saying what it would return. Yeah. And we can see that in our case, we didn't have to put this divided by, we didn't have to define the return type of a function to be a number, because by default, TypeScript knows that if you return a number divided by a number, you're obviously going to get a number in return. So let's try console.logging the exact same things we just did earlier. Divide two nums A, B, 6, 3, and console.log divide two nums of ACM and IEEE. And what we can see is that by default, it doesn't let us do this. And if you want to see why, let's hover over the error here. It says here, argument of type string is not assignable to parameter of type number. And really quickly, does anyone have any ideas on why like having this error message show up before we have to run the code, why it can be really helpful? Yeah, exactly, Jacob. It helps avoid some pesky runtime issues. Because the thing is, in plain vanilla JavaScript, what happens is that it doesn't tell us the error unless we actually run the code ourselves. And in some projects, running code in production or trying to test things takes up a lot of resources. And it's really hard to be able to find where exactly the problem is. But with TypeScript, it tells us where the problem is right away, which makes it so much easier for us to decide and be like, hey, it looks like the problem's here. I don't need to look around digging to see where the problem possibly could have been. So in order to run our code or to compile this to TypeScript, to JavaScript, you can just run the command yarn tsc. And what yarn tsc does is that it tries taking all of our code and compiles it to JavaScript. It looks like it says here, error, argument of type string is not assignable to parameter of type number. So it tried compiling, but it gave us an error, and it lets us know where the problem is. So right now, if we try doing the exact same thing of yarn_tsc, we can see that what the TypeScript compiler did is that it took our typescript.ts file and it made a JavaScript file, which we can run by simply running node typescript.js, like so. So quick recap, what we covered so far is how we can use the TypeScript compiler to compile our code in TypeScript and how we can assign types to things for static checking. Does anyone have any questions on anything we covered so far? All right. In that case, I guess another thing we can talk about is that saying how different, okay, we have a question in the chat. Is this valid JS? And let's see what happens if we try running node typescripts.ts. Let's see what happens if we try doing this. It tells us syntax error, unexpected token, colon. And that's a good question. And we can see that from this chart here, everything that is valid TypeScript, everything that's valid JavaScript is valid TypeScript, but not everything that's valid TypeScript is valid JavaScript, which means that like TypeScript is just a tool for us developers to write code that can be statically checked without having to run it. But at the same time, we can't run the code right away, which is why we need to do the intermediary step of yarn_tsc to convert all of our files from TypeScript to JavaScript that our node or our browser can run. Does that make sense? All right, nice. So moving on, let's go and take a look at some more things we can do within TypeScript. Oh, real quick, does anyone here have a dog or no, have a pet? If you do, can you put the name of the pet in the chat? Nice. Okay, so looks like we have a pet named Willow. And Sam, can you also put the, okay, so we have our pet Willow. Say Willow. And something we want to do, let's go back to let's put this inside of our JavaScript file. And something we want to do is that we want to greet Willow. So let's make a function, greet pet, which will take in a pet. And then we're going to console.log hello there. And then the name of the pet. So let's try doing that. Let's try greeting Willow and see what happens. Greet pet of my pet. And we can see that if we run our code, oh, this is in typescripts.js. I am writing this in the wrong file, I realize. My bad. Let me put this back to the scripts.js. And keep my pet there. And let's try running our code. Node scripts.js. We see that it says, hello there, Willow. All right. So looks like we made a function that says hello there to our pet Willow. And let's say that we are writing a bunch of codes, bunch of lines of code. And later on, we realize that instead of passing in a pet as a string, we want to pass it in an entire pet object. So let me ask Sam, what type of animal is Willow? Willow is a dog. All right. So in that case, let's go and refactor our pet object and say that our pet is now object. It's going to have a name, which is Willow, and it's going to have a type, which in this case is a dog. And now that we've done this, we're going to be good developers who refactors their code. So instead of greet pet, instead of saying hello there pet, we want to say hello there pet dot name. And let's greet our pet object. Before I run the code, do you guys think we're going to have any issues? No? Let's see. Let's see if any issues arise. Because it looks like, according to JavaScript, we're not going to have any issues at all with our code. We have no red squiggles anywhere. Let's see. It says, hello there, undefined. And looks like this is unintended behavior. And why is that? That's because it looks like we have had greetPet with the old implementation of myPet, which just takes in a string. And if you are refactoring code in the future, you might be mixing like your old usage of the function and a new usage of the function. And it can get really hard to see like what are things you need to change in the future. And like as Isha said, the issue is with myPet.name, because if you just pass in a string, then it looks like you cannot like know a .name of a string because there is no .name for a string. And let's see what happens if we try doing the exact same thing within TypeScript. Let's just copy and paste the entire thing where we have our pet Willow, our pet object. And first, we're going to want to say hello there to our pet, which is a type string. So if you want to console.log hello there with, oh no, you want to greet pet of my pet. You see that everything's fine and dandy, and we can do that. And if we want to see that, we can run yarn tsc, and then we can run typescripts.js. Hello there, Willow. And now let's try refactoring it to call it for our pet object instead. So let me ask you guys, what is the type of the object that we're creating? Like before we pass in a string, what type is pet? And you know what? That silence is actually a good thing, because with what we know right now, we have no idea how to describe like what is the type of the object, because it's not just a primitive type. It's like an object. And we can see that within the TypeScript, there are ways that we can define the types of objects. And the way we can do that is through something called an interface. So let's go ahead and make an interface for our dog. Let's call interface pet. And what an interface is that it's basically a way to describe what the shape is of the arguments or objects we're passing in. So what do you guys think all pets of our usage would have? Do you think all pets would have similar properties? Let's try putting one in here. So based off of what we're thinking, let's say that we want each pet to have a name, and each of their names is going to be a string. And we can denote the end of a property of an interface with a colon. And let's say they're also going to have a type, which is also a string. So now that we have made our interface of a pet, we can now say that this thing that we've made, our pet object, we can declare that to be of type pet using the type that we just created or the interface we just created, like so. Once again, what an interface is that it's like a description of an object that you're passing in. So now that we have made our pet interface, what do you think we can say is the type of the pet object that we're passing in? Pet. Let's try running that. Hello there, pet. And it looks like already off the bat, it tells us that we cannot pass in a string into our greetPet function because argument of type string is not assignable to parameter of type pet. So it tells us right away if there's some issues. All right. And real quick, let me show another really cool feature that we have within TypeScript. So within our function greetPet here, we see that when we want to grab the properties within our pet, if we run dot, it looks like it has all the different properties that within the JavaScript file, because it doesn't know what properties a pet can have. However, what I really love about TypeScript is that if we run the same dot property of the pet, it only gives us the possible properties that the object we're passing in can have. And this is really, really powerful because sometimes if you are making API calls, if you're doing a bunch of like complex code in the future, you don't really know if what you have like exists or not until you run the code, because JavaScript is dynamic. But the thing with TypeScript is that by having it be statically typed, you have more control in being able to see what you can see. So in this case, you can greet our pet object. We can compile our code, and then we can run it, saying, hello there, Willow. Perfect. Do you guys have any questions on something we covered so far about interfaces and why it's really nice to be able to type things? All good. All right. And one more thing I want to say is that within TypeScript, TypeScript is a duck typed language, which means that if it looks like a duck, talks like a duck, acts like a duck, then it is a duck. In that case, for instance, what we're saying is that all these objects here, if they have a name, which is a string, if they have a type, which is a dog, then we can say that it is a pet. Like for instance, if I said that the type was type 1 dog, it would yell at us saying, no, if you declare this as a pet object, you can't assign the type number to something that's supposed to be a string. And it looks like we have another question saying, if pet object had more data members, would it still be considered a pet? And let's see that. Let's try giving it a blood type of O, and it tells us, blood type string is not assignable to type pet. However, this also raises an interesting question, because if, say, for instance, you had your pet object, which is not going to be called a pet, but we said that it's blood type O, this code, in fact, still works, because this pet interface here, it assumes that what passes in has a name and a type. So while our like fancier pet object is not a pet itself, it has all the properties of a pet. And if you pass it into another function, it can be treated like so. It's kind of like inheritance and polymorphism, which we'll cover in CS32, but it's saying how like you can't specifically say that it is a type pet because it has extra things, but it can be treated as a type pet if it has all the properties as listed. If that makes sense, Arvind. Nice. All right. In that case, that we've covered some of the basics of TypeScript, let's go on and seeing how we can use TypeScript inside of our React applications. And let's try doing that like so. Let's go make CD out of this. And let's make a new TypeScript application. If you want to make a TypeScript application within React, something you can do is just say yarn create React app. And then you want to say a template. So it's -- template TypeScript, the name of our project. In this case, we're going to say, let's call it typed React. Cannot create a project named typed React because of naming restrictions. Okay, my bad. Let's call it typed-react. And like we said before, this does almost the same thing as npx create React app or yarn create React app, except it adds in the TypeScript compiler for us. It compiles all of our TypeScript code to JavaScript code, so we don't have to run yarn tsc every time we do something. Give it a sec to load up. And looks like we have our TypeScript version of a React app. And let's cd into that. Type React. And now that we have typed React, let us open it up. Yarn start in order to start a development server within React. And we can see that it looks almost the same, except it says edit source / app.tsx and save to reload. So why don't we take a look at our source code and see if there's anything that makes it different from regular React. go into typed React and app.tsx. Right off the bat, you guys might notice that it looks almost exactly the same as if we were to use regular JavaScript version of React. The only main difference is that instead of app.js, we have to call app.tsx. And this is because by calling it app.tsx, we are telling our computer and our compiler that this is in fact TypeScript code, which uses JSX. But in our case, it's no longer JSX, it is TSX, because it uses TypeScript instead of JavaScript. So why don't we go ahead and try doing some stuff within our code. Let's make a component. And let's call this component greeting. And we want to greet someone. And let's make our person be, in this case, let's call it Advait. Hello there, person. And let's try grabbing our greeting component, like we learned last week of how we can make components. And let's see. Oh, wait, real quick, let me just double check. Have we covered how to make components yet within React? Can someone who was here last week? All right, in that case, we'll just go over like a quick demonstration of like what exactly a component is. And what a component is in React is that it's a way for us to like break apart the code that we write within HTML and like break it into different sections. So what this is here of saying hello there person, this is basically saying that I want to be able to say hello there to someone, and I can grab this component by calling it like so. So let's go see. It says hello there, Advait. And this is not inside the A. Let's put that inside of our P tag. There we go. And now let's see what we can do with props. And if you remember from last week, within components, what you can do is that you can pass in things to differentiate between components with something called props. In this case, let's pass in our person, and let's say we want to call it person is Advait in this instance. And we see that right away, TypeScript is yelling at us. Let me try doing this. That's because it says type person string is not assignable to intrinsic attributes. And that's kind of weird. But we remember that what we have to do is that when you try grabbing props from a component up above, you have to pass in props like so. And it tells here, props is declared but never read. Props implicitly has any type. And we have to define what the shape is of the props that are passing in. And the way that we can define the shape is, do you guys have any thoughts on how we can describe the props object being passed in, going off of what we learned with TypeScript so far? Interface. Yeah, let's try doing just that. Let's make our interface, let's call it greeting props. And what we want to do is that we want to take our props, and we know that our props pass down, we're going to have a person, which is of type string. So now that we made this, we can define our props to be greeting props. And instead of putting person here, we can say hello there, props dot person. And we can see that if we do this, it has the exact same outcome. Real quick, do you have any questions on how we're able to use TypeScript in order to type our props in the interface before passing it in? All right, cool. In that case, we're going to cover some more things within TypeScript you could do within React. Another cool thing you could do is an enum. So let's say that within our greeting property, we want to greet a bunch of different people. And let's say that the list of people that we can greet is going to be like, you want to greet Advaith, Matt, and also Evan and Tina. Let's say you have these people that you would want to greet. And the way that if you want to say that you only want to greet a specific type of people, is through something called an enum. And let's see how we can make that. Enum, people, greetees, people who you want to greet. You can have Advaith be equal to Advaith. You can have Matt equal to Matt. Evan equal to Evan. And Tina equal to Tina. And let's see what this allows us to do. Normally, when you make an interface with something like a person, you say that you can pass in any string. However, for something like an interface or with an enum, if you pass in greeties instead of string, what you can say is that inside of your props, you cannot say like, oh, Advaith is not assignable. And something you can do is that you have to say that your person is of type greeties dot Advaith. And real quick, does anyone know some possible ways that we could use enums like this and why it could be helpful? And like if you look at our code, we say that it does the exact same thing, saying hi to Advaith. Like if anyone wants to spitball on how this could be considered helpful for us. In the meantime, I'll try adding another greeting. And let's say that we want to put person equals to say greeties.mat. And looks like we have an answer in the chat. It says here, interface, could you map over the enum? And in fact, you probably could, I think. Let's see. But the main reason why you would want to do that is that can you map over enum? You can, but it's very finicky. But I think that, in my opinion, the main reason why you would want to use an enum is that if you want to pass in like specific props that can only be certain things. Like let's say, for instance, you had a function that had a switch statement. Something really cool you can do with enum is that you can basically make sure that the thing that you're passing in is always going to be of a specific type within a switch statement through an enum by only giving certain values that can be passed down. Does this kind of make sense on how you can use enums to pass in and guarantee that in React or in anything, you only get certain values? All right, cool. In that case, let's go ahead and talk a little bit more about some extra things you can do within React. And let's see. Actually, some more. Let's do some state variables. So last week, I think we covered how you could use state in React using the useState hook. And let's go ahead and do that right now. Const. Let's call this count, set count equals useState 0. Let's have a button like last time, which can increment our count. You counted count times. Make our button real quick. Set count plus 1. And let's go ahead and make our button say, click me. Nice. So now that we have our useState variable here, something else that we can do is that we can, within TypeScript, if you want to give a specific type to your useState, you can use something called a generic. And generic is these angled brackets here, which mean that inside you can say what the type is of your useState. Like, let's say, for instance, you want to start it and say, click me. And then once it's clicked, you want to make it so that it starts from 0, it starts from click me, and then starts counting 1, 2, 3, 4, 5, 6. Like, say, if count equals click me, and you're going to want to set count to be 1. Else, you're going to want to do that. And if you want to have this mixed things of strings and numbers, something you can do is that you can put an or operator. You say that our count is going to be a number or a string, like so. Oh, it says else count plus 1. Operator plus can't be applied to type string or number. Let's see. And this is something that TypeScript allows us to do, of being like really strict and saying, oh, what if it's possibly a string in this scenario? So something you can do is that inside of your else statement, you can daisy chain a couple more statements, being like, if the type of count is equal to a number, then set count plus 1 to check and make sure that when you're trying to do something, you're making sure that it can only be a number. And let's see what this does. It did not work in that case. Let's see why. All right, I think there's something wrong in this scenario I just made up here. But as you can see, what we can do is that if you have useState to be multiple types, then you can in fact use this operator here to separate them, like so.
I think it was because you had a space in your string. Like,
oh yeah. Thanks, Jacob. Let's see if that is correct. Nice. And it turns out that was in fact the issue. Thank you. All right. So now that we've covered a bit about state, do you have any questions on how we could use the or the pipe operator to like distinguish between different types of things if state can take on multiple values? And real quick, something that can be really helpful for this is that, let's say you have your state storing like a pet object like before. And initially it's going to be null because you don't know what type it is, or you're not going to know what it is. So like in your code, this can be really helpful if you set it off as null, and later on down the line, you make it become a pet. That's just a quick example of something of when you would want to use this. All right. In that case, if you don't have any more questions, then let's move on a little bit to some extra things we can do within React. So looks like what we've worked on so far is that we've looked a little bit about how we can use the useState hook in order to keep track of state within our React apps. And today we're going to go over ahead and look on what are some other possible hooks we can use and why they're necessary. And first, to talk about this, let's take a look at the React Lifecycle and talk a little bit about how React works. So real quick, something that people really love about React is that when it updates, it only updates specific things when they need to be updated. And what do I mean by that? Like when you press click me here, it tries not to update things that in fact don't need to be updated and only update what needs to be updated. And the reason, how it does that is that, let's take a look at some of our React apps. And we can see that within React apps, there are, or within React components, there are two ways that they can change. They can change if the state within them changes, and they can change if the thing that's passed down, props, changes as well. And what React does is that it's able to determine whether or not to update based on if the props change or if the state inside changes. All right, now that we covered that, what we can also find is that within React, there's something called the lifecycle of components and how exactly these things work. So when you first refresh the page, oh, we have a question in the chat. Is it lagging? Am I lagging? It said my internet connection was unstable for a bit. Am I good now?
Yeah, it's usually just for a few seconds.
All right, sounds good. Thank you. So now that we covered a bit about how we can get things to update, let's talk a little bit about the lifecycle of React apps or React components. When you first open a page, or when something first gets onto the page, it is called mounting the page. And we call it mounting because it means that it first gets shown onto the screen for the first time. And whenever something updates, it is called the component updating. And when the component goes off the page, we can call that as the component unmounting. If you want to take a look to see what exactly we can do within lifecycle methods, then we can look inside here. And you can see on this write-up here that discusses a lot about the state and lifecycle within React components and what exactly like mounting, unmounting, and updating can do. Now, first, in previous iterations of React, if you wanted to have control over the lifecycle of a React component, what you had to do was that you had to do a lot of different methods like component did mount, component will unmount, or component did update to do things whenever the lifecycle of a React app or a React component gets reached. However, inside functional React, the new version of React, which we'll be using for most of our projects, we can see that you don't need to do all these separate lifecycle methods because there is, in fact, a hook we can use which handles all of them encapsulated into one. And let's see what that is. That hook is called useEffect. And let's see what exactly we can do within useEffect. So the way that we can use the useEffect hook is that inside of our React component, at the top level, you have to say useEffect. And useEffect takes in two things. It takes in a function, and it takes in a dependency array. And first, let's break down some things that happen. Log, I am on the page. I mounted the page. You can see that when we refresh our React app page and look in the element, console says, I mounted the page. And if we click on the element, we see that this only runs when you mount the page for the first time. So we said first is that the first thing useEffect takes in is that it takes in, let me show the example with some annotated things so that we can see easier. Here we go. So what it says here is that we can write in a function that runs whenever something inside the dependency array changes. And then inside of your return statement, you can you can also have a function that only gets run whenever the component will unmount the screen. And here we have an optional dependency array. What the dependency array means is that we are only going to run this function whenever something happens or within a dependency array. Let's say, for instance, I wanted to keep track of whenever the count variable changed, like const.log saying count changed. Const.log this, we can see and add count into our dependency array. Oh, I'm going to put this below our use state of count. And what we can see is that if I look here, it says count changed, and it gets ran every time the count variable changes. Very cool. Later on, after the break, we're going to talk a little bit about where useEffect could be helpful and why we could write this within our React apps. And for now, we can see that we are able to write our function, and we can determine whenever this function runs by the dependency array. If our dependency array is empty, this is the same thing as saying, I only want this to run. Connection unstable, sorry. It's the same thing as saying, I only want this to run the first time when the component mounts. But if you add in this dependency, you say, I only want to run this function every time this value changes. Does anyone have any questions on the useEffect hook that we just created here and like how we could use it? All right, so in that case, let's talk a little bit more about hooks before we go into a whole bunch of other hooks after the break. So real quick, what we've seen is that what we've used so far is that we've used useState to keep track of state variables or things that can change within React. And we use useEffect to keep track of what we want to do and when to do them through the dependency array. And it turns out that, sorry?
I think Arvin has a question in the chat.
Oh yeah, if you update count in useEffect, is there a loop? Let's see if we can do that. You want to set count to be count plus 1. Let's see what happens if we try doing that. Okay, and let's change this back to just a number and make this 0. And then button on click and on click, we just want to set count to be 1. Let's see what happens. As you can see, it's saying here, warning, maximum update depth exceeded. So what happens is that what we have here is that we have basically an infinite loop, because if we try increasing count, we're going to trigger the function, and it's just going to keep running over and over and over again until we break the app. Okay, it looks like we have another question. It asks why, if you have count in the array, it runs the console log function when you reload the page, although the count hasn't increased yet. And let's see why that's the case. Go to localhost 3000. And we can see that the reason for that is because of our useState hook. With our useState hook, we can pass in a default value that we want it to be set to. In this case, by setting it to 0, we say that when the component first mounts, we want the value of count to be set to 0. So even though we haven't changed the value of count yet, by simply mounting the component, because of the default value we put into the useState, we are triggering the useEffect function to run, because we are also setting the value of count to be 1. Yeah. All right. So in that case, let's go over a bit more about the useEffect hook and hooks in general within React. So when you use a hook in React, something that's really important is that there are a couple main rules of React hooks that you must follow. The first rule that you must follow is that you can only use hooks at the top level of your function or at the top level of your React component. And what do you mean by the top level? Well, the top level means that you cannot use hooks like useState or useEffect inside of conditionals like loops or if statements. You can only call them if their highest block scope up above is the component that you were calling them in. Does that make sense for when I say that when you call hooks, they can only be at the highest level of the component you're calling them in? All right. Another thing that we have to cover is that when you are using React hooks, Another thing is that you can only use React hooks inside of functional React components or something called custom hooks, which means that if you're having a plain JavaScript function like greet, and then you cannot use the useState hook inside of here because that is a no-go. You can only use hooks inside of React components or custom hooks, which we have not covered yet. If you want to see a complete list of all of the possible rules of hooks, you can just search up the rules of hooks above. You can see here are the main hooks rules saying only call hooks at the top level, and you can only call hooks from React functions. All right. Are we good on, now that we've covered hooks of useEffect and useState, do you have any questions on how they work? All right, in that case, we're gonna take a quick 5-minute break here, and we're gonna come back at 8:03 to continue the rest of today. All right, welcome back from the break, everyone. And so today, right now, we're gonna talk a little bit about some more hooks that we can use within React. Remember, so far, what we've learned so far is useState and useEffect. And we're gonna go ahead and learn some other hooks that we can use and some use cases of why we want to use them. And first, let's cover a really important one, I think, which is called useContext. To describe why we might want to use context for things, let's see how we can make some pages based off of what we know so far with useState, useEffect, and props. So let's take a look at this page we have right here. And what this is that we have a component, a parent component here, and all of its children, or its children that is 2 levels down, requires some of its state variables. And based off of what we know so far, what are ways you think that we can pass down the state variable from here to its children component down here? And if you want to see some of our code that we have is that we have our main page, we have our intermediate component here, which is brown, and we have our child component, son and daughter component down here. Well, let's see. With what we have so far, I think that the way that we can pass down the state through both of its parents, to both of its children, is through props. So we have our main page here, window with prop drilling. We have this parent component up here, and we have these smaller components down here that also rely on that change. So what we have to do, sadly, is that we have to define the state inside of our top component, and we have to pass it down all the way to a children component at the bottom. And what this means is that even though this parent component here doesn't rely on the width and the height, both of its children do, and we have to pass it down. There's something called prop drilling. And to see a better view of what exactly prop drilling is, let's take a look at our write-up. And this is an example of what we're doing right here. What we do is that we have our data that's within our container component, and we're passing it down throughout its entirety of the tree. And when we say tree in React, that means that it is the component and all of its children that are children of that component within the tree. So what we do is that we have our data inside of a container component, and we pass it down level by level into our children, like so. Now, this can be a bit weird at times. Like for instance, something that sucks with this approach is that if you have your state logic, you have to pass it in through the green intermediate components which don't even rely on that logic, but the children component in fact do. So what this means is that you have to forward your props through components that don't even need to use it. And prop drilling also has some pros as well. With the approach of prop drilling, what's nice is that the child component is simply a consumer of the state logic up above, which means that the flow of data is always from parent to child with linear exchange of data. But however, at the same time, some of the cons of this is that it becomes harder and harder to add things to pass down the entirety of the tree. For instance, inside of our component here, what if we wanted to add like another variable that we wanted every single thing within every single component within our tree to listen to? Like what if, for instance, we had a const favorite number component or favorite number state variable equals use state 0. If we want to pass it down through the entirety of our components, we're going to have to pass it in to every single child and pass it into props, which takes a lot of work. The problem with this approach is that when you're passing down props of something you change or something you delete, you might accidentally miss something and you might not know that. So now that we talked a little bit about the cons of prop drilling inside of this little handy dandy little graph here, let's see the other approach we can take within React context and how it can be different. The main thing with React context is that instead of having a linear flow of data from here and it's just pipelining all the data down to a children component, what React context allows us to do is that we're allowed to make a content container, and everything within the tree has direct access to the content. And this style of thinking of having one container handle all the data is something called a higher order component, which means that you have a higher order component which controls all the data, and everything else is just simply reading the data across from it. And there's pros and cons to this approach. But before we go over that, let's go over the pros and cons right now real quick. Sorry. So for the pros and cons of this approach, let's see what can be nice with context. A really nice thing about this is that we're able to have centralized state logic, which means that instead of having to pass things down through entirety of trees, we know that everything that can change is only inside this context container that we have. And this allows us to also achieve something called global state, which means that we can add and remove context, add and remove logic really easily, and we don't have to go through and add it individually for each child. So in that case, why don't we go ahead and try implementing context right now and see how we can add that inside of our React apps. Real quick, does anyone have any questions on the pros and cons of prop drilling versus the usage of context that we talked about real quick? In that case, let's go ahead and try to create the context container that we just discussed. So let me go comment this out. And let's see, first we need to keep track of a context container. So let's have our React function. And let's call this window dimensions container. And within our window dimensions container, we want to be able to keep track of all the logic that we had, like so. As we can see, what logic that we want to keep track of in our current function is that we want to keep track of the window's width and the window's height across the entirety of our component tree. And give me a sec. So let's go ahead and grab the logic to do that right now. So we have a function get window width, get window height, which is something we can just do within the global window in JavaScript and TypeScript. And let's make a useEffect function to set up a listener for that. And we want to, let's say we want to keep track of the window width with the state variable. Zero, and then let's say const window set window height, also be a state variable. And now we're going to set up an event listener to say like, okay, whenever the window's width changes, I want to listen to that and change it accordingly. The way we can do that is through the handy dandy little hook that we learned earlier, useEffect. So now what we can do is, I forgot the exact syntax, but we want to have a function called handle resize. And what this does is that this is going to get the window width and the window height from our global window. We want to set it to be our state variables. And now we want to add an event listener to our entire window that says on resize. I want to call the handle resize function. And because this is an event listener, we want to only run this. We will only want to add this when the component first mounts. And then we can say like const. And now this is where something that we covered earlier about the return type and the returning of a useEffect can come in handy. Like let's say we have our event listener here. We have to give it a name, let's say window listener. And whenever you add an event listener in JavaScript or TypeScript, it's always going to listen until you tell it not to. And the way that we can tell something not to listen anymore, if you don't need to, like let's say in our case, we don't want to listen for, what's it called? If we want to tell our component that we don't want to listen to it anymore because we're no longer on the page, the way we can do that is with our return of the useEffect. So we can pass in a function that says when the component leaves the page, we want to remove the event listener. Like, it's yelling at us saying, why is that the case? Do I have the code wrong? Window.remove event listener resize handle resize. There we go. Resize handle resize. All right. So this code here says that we want to add the event listener and remove the event listener to listen for changes. So what we can see is that right now in our container, this handles our width and our height. Now, the question is, how can we pass this in to all of our other components within the tree? And the way we can do that is through something called, as we said before, a higher order component, which means that we are going to return. Apologies, let me take a step back here. So right now we have all the logic to keep track of the window width and the window height. And this is going to be our container object, or if you look here, this is going to be all of the data, or this little gray box, which contains all the data that our things can listen for. Now let's see, how can we go about using it and creating that? Well, first, what we can do is that we say that when we pass it in, we are creating something called a higher order component. Let's say that this is window container props, and what the window container contains is that it contains children, which is going to be a React function or a React component. The way we can denote a React component is by saying jsx.element. And within our React component, like so, we want to say that we want to be able to grab it and return it. When I return div, oh, I'm forgetting something. Apologies. So with what we have right here, we have all of our logic in order to set up our context container. Now we have to say, what do we want to pass down for all of our children components that we need in the future? Let's see. Let me uncomment this out real quick so that we can see what it's supposed to look like in the end. And looking at it, what do you guys think everything needs to keep track of? Or what do we want to pass in through all of our different trees? Is there anything in particular you think that we need to keep track of and pass in that our children would want to use? Well, looking at this, it looks like, yeah, exactly. We want to pass in the width and the height. So let's go ahead and make an interface for the value of the context container we want to pass in. Let's call this window context. And then with the window context, we want to pass in a window width, which is going to be a number, and a window height, which is also going to be a number. Now we can use something called create context to create the React context that we're going to be passing in. So let's say const, window context type. Let's say our window context is going to be React.create context, and says our create context needs to get a default value to pass in. So for now, we have to also make a default window context. Let's do that. Const default window context is going to be of type window context type, and we have to give it default values to pass in. In our case, let's say we want to put window width of 0 and a window height of also 0. And we're going to say that we want to create a context, the default values of default window context. Nice. So now we have made our window context like so. Cannot declare, okay. The reason why I think is because, let me re-comment out this stuff here. And let's go. So now we have made our window context like so. The only problem is now, how can we pass it around through all of our components? The way we can do that is with this window dimensions container here, we can use something called context provider. And let's see what exactly a context provider is. Well, a context provider, if you go and say window context.provider, I'm going to go ahead and do it right now, and then I'm going to explain what exactly we did right afterwards. All right, so what we are doing is that within our window dimensions container, what we're doing is that we are creating it and saying that it is going to be the provider of the context for its props.children. In this case, what its children is going to be a React component, or in this case, it'll be a React tree, which contains all of the data that we want to read. And by passing the value, we can press Control space to see what we need. And look at that. We need to pass in a window height, which in this case will be our window height. We can make our window width. Oh, something is buggy. Let's see what is happening. Window width being window width. And let's see why it is yelling at us. Type window height number is not assignable to type number. Wait a sec. Huh? window context.provider. Value equal, oh, okay, I remember I'm doing wrong. Okay, whoops. It should be window height, comma, window width. There we go. There we go. Now it's working. So what this is that we're saying that for our entire tree, we want to pass in all this data below like so. And now, how can we use this? Well, the way that we can use this inside of our tree, let's go uncomment out all of our components like so. And we have our context page. And we have our window dimensions. Let's call this window dimensions provider. We have our window provider. And we can say that in order to pass in our context container, we take in our entire page and we wrap it inside of the window provider, which means that all of our page before, as so, all of this now is able to grab the width and the height, which is set inside of our context provider. Do you have any questions so far on what exactly we did in order to create our context provider in order to essentially create the gray component to pass in all the data? Afterwards, we're going to talk about how we can grab the data within our component. And once again, by wrapping this inside of a window provider, we're saying that originally our page, which didn't have anything, now it has this extra data on top of it, which we can grab. All right. So in that case, something we could do now with context is that now that we've discovered how to make this gray box, let's figure out how we can grab the context from the container within our components. And the way we can do that is through the useContext hook. Let's see how we can do that. Within the useContext hook, within our sun component, which uses the window width and window height, what we can do is that we can grab the window width and window height values from our context by saying useContext, window context. And we can grab the values that we need like so with window width and window height. And remember, when we use useContext here, we can only use the useContext hook if the component that we are a part of is a listener or is wrapped by a window context provider up above. And what we know is that within React, if the container component, which we have the biggest one, is wrapped within our context provider, everything within the tree has access to the context, like so. So let's go ahead and inside of our daughter component, let's do the exact same thing of grabbing the window width and the window height from the context. And we can see that when we refresh the page, it is working like so, where the daughter and sun component is able to grab what we need from the context and use it. So real quick, does anyone have any questions on how we set up the context with set up outside our component as well as within our component? Setting up context can be a bit tricky. So if you need to take a look in the back at it, we have the guide on our page as well of how to set up React context both inside and outside your component. Because the main thing with it is that the problem, what makes it different is that for other hooks like useEffect or useState, you only have to have set up outside of your component. However, you only have to have set up inside your component. However, with hooks like useContext, you have to set up things outside your component that you want to use it in as well. Now that we've talked a little bit about context, let's see about the pros and cons that this can have over something else like prop drilling. And let's go here. And let's see the pros of it. And with pros of React context, this allows separation of concerns across multiple things. For instance, if you look inside of our son and daughter component, they no longer need to care about like state variables, because what we do is that everything that you need to care about state or things that can possibly change is all inside of this one window provider, which controls all the state variables, which means that with higher order components or React context, we're able to separate things into things that handle all of the logic and components that only handle displaying the logic below. And we can also avoid having to rewrite code multiple times. Like for instance, let's say we wanted to pass it down through multiple trees. With prop drilling, we remember that we had to pass down the props from the top state through each level of the tree. With context, you don't have to do that because you can simply grab it from anywhere along the tree by using the useContext hook. But again, some things with React context is that not everything is always going to be fine and dandy. Like for instance, with the context, there's some extra re-rendering rules that we have to go into play. Remember how earlier we talked about with React, it knows to update the state of something based on, it knows to update how something looks based on state or if the props change. With context, that's a bit different. With context, because everything is listening for the state values that's stored inside the context container, once something changes in the context, all components within the context have to get updated as well. So whenever you use context, you have to think about it and be like, is it worth the little bit of updating this happens? And most of the time, it's not a concern. So it can be used if it makes development a lot easier. Do you have any questions on the difference between prop drilling and context and how we can pass down state and different variables across the entirety of a component tree? All right. In that case, we can now cover and see something else we can do in React. If you're looking along, you can see that what I was able to do now is that by clicking along these different pages on the top, it looks like we're able to make multiple different pages within our React component. And being able to make multiple pages or seem like you're having multiple pages is really important. So now we're going to take a look at the React router and how we can use React and make multiple pages within React. So give me 1 sec to get set up. So right now I'm inside of the context example, and now I'm going to switch out and switch to our router example. And let's go ahead and start this up. All right, so now we have our page. What you can see is that here we can have multiple pages throughout our React app. But before we go into how we can make it look like we're across multiple pages, let's talk a little bit about the internals of React and how exactly things work. First, let's take a step back and look at our regular website. In this case, like ACM, UCLA ACM by TeachLA. With this website here, this is a static website, which means that when you click on a page to go into different tabs, you can see that everything is, it goes to a completely different page itself. Like this is its own index.html file, classes is its own index.html file, and so on. However, React is slightly different. If you look at the internals of a React app, you can see that if you look inside public index.html, what's really interesting is that the entirety of a React app is actually all contained within a single index.html file. And what does that mean? That means that in this page here, even though it looks like we're completely changing how the page looks, that's not true because we are only confined to a single HTML file. And now let's see, how does that make that different from something like TeachLA's website, which is static? And the way that makes it different is that this has multiple indexed HTML files, while our React app is only one. And having multiple pages, but having it feel like there's multiple pages while you're only on a single HTML file actually has a name within web development. And that is called a single page application. And let me go back to the notes here. And what the single page application is, means that we can make it feel like we're going across multiple pages. However, what we can see is that if you look down in the internals, it's actually just a single page that looks like it's being crossed multiple times. And the way that single page applications work is that when you run npx create React app, you basically generate a server that takes all your files and condenses it all into be able to be a single page. And you can change how it looks through something called the React router. But let's see what the React router is. If you search up React router DOM, you can see that it says here, React router is declarative routing for React apps at any scale. Oh, interesting. Looks like their page might be down. Is my internet down? Can you hear me? Did I cut out for a second? So I think I froze.
Yeah, I think you were frozen for like a good 2 minutes, not 2 minutes, but like a good minute or so.
Interesting. I guess in that case, can someone update me on where we last were? Do you remember what I was talking about? Oh, only 20 seconds. Do you remember, like, were we talking about like single page applications, maybe? Yeah, okay, cool. So sorry about that. So I guess a quick recap, if I cut out, is that single page application means that we can emulate the feeling of multiple pages, even though we're only on a single page ourselves. All right, now that we've got that out of the way, let's go and see how we can use that through the React router DOM. So if we have multiple pages here, let's take a look at an example of something that's already made and kind of dissecting how the code looks. Let me close all these tabs. And let's take a look at the React router example, which is here. All right. So what we can see is that within the React router, we have, looks like it says a router, we have links, and we have routes. And let's see what exactly all of these things do. Within the React router, something you can do is that if for the root of your app where things can change, you just have to wrap everything inside of router like so. And you can just import it like
Or is
import.
that just me?
Looks like I have frozen as well, apparently.
Okay.
Interesting.
Yeah.
I think what we can do is that I can record this part, but if you want to see in more detail things that we're covering right now, I'm going to go show this real quick. TeachLA actually went over these things of how we can do this. And all of these concepts that we're talking about today are already within a playlist you can view. And if you want to see where it is, we can see that we have these React modules that cover a lot of these things, like Intro to Typescript, React modules of single page applications and internals, use reducer, as well as useContext. And all of our write-ups can also be seen as well. So I apologize if I froze for a bit. And if there's any like gaps in the knowledge, you can always go back and check our repository and check our videos for a better view of things we might have missed. All right. In that case, am I frozen again? No. All right, nice. Okay, let's go back and see how we can use the React router. This example here, we have a bunch of router, we have link 2. And as it expects, when we try clicking on something that says link to slash, we go to the base of our page. And for this, in this case, where it says link to first page, when I click on that, we see that on the router on the top, if you look at the URL, it changes to first. And let me go comment this out real quick. Let's switch. Sorry, let me just comment this out. All right, so we can see that within our page here, when you click on first page, we get slash first on the top, slash second on the top, and finally slash random number on the top. So we can see that within our page here, we're able to change what happens in the URL by writing a link to. So do you have any questions on how we can write links to change the URL of our apps? Nice. In that case, now that we've talked about how we can use the links in order to change our URL, let's see how we can change the things that show up based off of our URL. The way we can do that is through something called a switch. So within a switch here, let's say that in a switch, what we can say is that we want to change what shows up depending on what it looks like and depending on what our URL is saying. So within each switch, you can write a route, and you can also write a path of your route. So within the path, let's say that if we want the root of our website, we can have a root here. And what is this page called? This is called the name of our page, which is the first one is, let's say it's nothing. Let's say click on the top to get started. Let's see. We see that when we refresh, it says click on the top to get started. And now let's add another root that we want to change. Looks like we want to have our first page show up when it says first. Let's see how we can do that. Root path equals slash first. And then we want to add in what we want to show. And let's say we want to show our first page. And let's see what happens. If we try going on to first page, it looks like it's not showing up. And why is that? Well, that's kind of how switch works. Switches work within React. The reason why, so when you're making routes within a switch, what it does is that it tries to go to the one that matches the route first, which means that in this case, when we have slash, our URL has a slash in the beginning, and since it's placed first in the switch, it's going to go to that. It's going to say click on the top to get started first. However, if we go back and change this to go on the top, we can see that on first, it properly gives us the first page instead. And this is because within React switches, within the React router and switches, it tries to match the thing that shows up first within the code. If you do not like this approach and you want to make it so that you have to match something exactly, you can easily do that within the React router. And the way you can do that is by saying you want an exact path. Or in this case, this can be a bit weird. If you want to see how this works, this is basically saying exact equals true, except it's a shorthand way of saying it and just calling exact. Similarly, we can do something else with route path equals second and pass in the second page. Base page, first page, second page. Nice. And within routes, you know how sometimes within pages, you can have a 404 page. Like if you try writing in whatever, it says 404 page not found. And actually, we can do something very similar as well and by writing a 404 page not found if a URL does not match. The way we can do that is by saying route path equals star. And what the star does, it says, oops, not found. And what the star is that it's basically the same thing as a 404 page, saying that if you say something that isn't addressed, you can give an error warning within your page. So once again, something cool that you could do with React Router is that you can essentially make different pages that you want show up, simply different React components. And you can change which gets displayed on the screen by using switches and routes, as well as changing what happens in the URL with links. Do we have any question on anything we covered so far? All right. In that case, we can talk a little bit more about single page applications in React and how that's different from from normal web applications. So something that can be really cool is that, let's say we have our index.css or app.css like so. First page. Oh, 1 sec. Oh, wait, never mind. I think in the interest of time, oh, wait, am I cut out? It says that your connection is unstable.
You're back now.
I'm back. All right. So in the interest of time, we're not going to need to cover some more. We don't need to cover like single page applications, but if you want to learn more about single page applications, as well as routing and parameters, you can check out this video here where we talk about React internals, single page applications, and the React router. And you can see a more detailed view with the repository down below. Nice. So as a quick recap, things that we covered today in this jam-filled session. What we covered is that we've covered how we can use TypeScript within React applications and why TypeScript can help solve some of the common issues with JavaScript. Some of these common issues we talked about were that if you refactor code, JavaScript doesn't tell you where your issues go wrong, but with TypeScript, you're able to find these issues right before anything happens without even having to run your code through static checking. Also, we covered how we can keep track of the React lifecycle through the useEffect hook and learning how to keep track of what happens and when within your React app. And we also talked about how with useContext, you can track your data throughout an entirety of separate trees within React components through simply using a context container and how to set that up with the concept of higher order components. And finally, we talked about how we can emulate multiple pages within React through the React router. And we learned that even though React is a single page application and it's a single HTML file, we can use the router to emulate the feel of multiple pages. I think this about wraps up things that we can cover for advanced React topics, as well as TypeScript. And in the future, we have, so essentially what we've covered is that we've covered almost everything we need to go ahead and create amazing dynamic websites. In the future, we'll learn a little bit more about how we can do things fully end-to-end with some back-end development, and keep in tune to see what else we can learn. All right, I'm going to stop the recording now, and yeah.